Hello everyone, and welcome to Introduction to Programming with Java. My name is David Allerton, and this is Lecture 1. We're going to be going from the calculator to the computer, looking at expressions, assignment statements, programs, types, names and strings, conditionals and alterations, and the ternary operator. And that's about it for this lecture. It's really just getting us started on what a programming language actually consists of. And what Lecture 1 teaches us is the difference, or some of the differences, between the most basic of calculators and what we expect a computer program to be able to do. And we see that in expressions, assignment statements, and programs in section 1.1. So you see with this assignment statements in 1.1, we have some what we would routinely call basic algebra. X equals 2, y equals x plus 1, x equals x plus y. So if we follow that through, we know x equals 2. On the second line, y then must equal 3. And then we know that 2 plus 3 equals 5. So x is now assigned to the value 5. Awesome. Now, this also could be called a program. It's a program of utterly no use to us, but it would work as a valid program. Here's another example of a program which just prints hello world. Again, not of much particular use, but as we can see, we can compile and run the program, and it will go through and print the line hello world for us. So let's move on to types, names, and strings. As we see, we've got this exercise on 1.2, splitting out keywords, strings, and identifiers. Now, keywords are a list of reserved words in Java. So at this point of the lecture, we're kind of moving into some more Java-specific features. And we have strings, which are a chain of characters, and identifiers, which could be variable or function names. Now, for keywords, it's really a lot based on your familiarity with a language or multiple languages to know which words you really shouldn't be using as variable names. In fact, there's actually a list of reserved keywords in Java, about 50 of them. We can find these on Wikipedia. We see a list of Java keywords. And we can see we've got all of these different ones, from abstract to byte, catch, class, continue, default, else, if, for, import, and so on and so forth. And private and public, which you may have seen already. So it's really just a case of being familiar with the language, and up until that point, you'll just know that there's 50 of them, so it's unlikely you'll accidentally use one, and if you do, everything will go wrong. So it's a very easy error to make, but one that's often noticeable straight away. So let's have a look at this exercise. And we see we've got int here. So it sounds like a type, a variable type. But if we're not sure, we can have a quick look here. And there it is. The int keyword is used to declare a variable that can hold an integer. All right, so this sounds like something that would be a keyword. Now here we have the same word int, but in double quotation marks. Now if we remember from one of the previous videos we've watched, characters are held in single quotation marks, and a chain of characters, or a string, is in double quotation marks. So even though this looks like a keyword, because it is in double quotation marks, it's a string. And then let's have a look at bool. So bool seems like a shorthand for Boolean. So maybe this is a bit of a trick question. Boolean is a reserved word, a keyword. It can be a value which is true or false. But bool is a shorthand for this. So maybe we would use that to store a true or false value in. But let's check if this is actually a reserved word. And we see that it's not, but Boolean is. So we know that this bool or could be used as an identifier. All right. I think, the rest of these we can figure out for ourselves. Let's move on to conditionals and alternatives in Java. And maybe a little surprise with a bit more advanced programming here for you to get stuck in with. So with conditionals, the first thing for us to look at is this non-graded activity on the body mass index. So we have a definition of what it is. Mass of the person divided by the square of the height. Great, and so in this exercise you're looking at putting some of these operands into these conditional statements to make the correct categories for the body mass index as described above. But before we get started into that, let's just run through some of these operators. So we have plus, minus, times, divide. This is the modulus operator, not percent, as we would usually know it. And what modulus does is it tells us the remainder after a division. But we can have some more fun with that a bit later on. And this is less than, and I'll just scroll across. This is greater than or equal to, not equal to, and, or, and that's it. So we don't have that many here, nearly all of them, but enough to get started. So we said it was mass divided by the square of heights. Right. So what we're going to do is we're going to use divided by, and then in order to get the square, we've got height and height, so we just need to times them together. And then according to this up here, we can see underweight is less than, and then we've got greater than and equal to, and less than, greater than and equal to, and less than. And I'm sure from that you'll be able to work through the rest of this question without any problems at all. I mentioned it would be cool to introduce a random number generator, and the exercise I was thinking for that was this alternatives in Java solution. So what I've done is I've copied across the code into codeboard, and we can see we've got these goals home Barcelona, goals away Barcelona, goals home Madrid, goals away Madrid. And what is suggested we do in the edX course is that we change these values to see what happens. And depending on the total goals, the goals from Madrid are greater than the goals from Barcelona. We print Madrid passes the round. If it's the other way around, Barcelona passes the round, and then else they have to play extra time. So if we compile this, compilation successful, and we run it, we see that every time this result is going to be 4-4. So how can we make this program a little bit more interesting? Well, what we can do is make the home and away goals random. Now, I've searched Google for how to generate a random integer within a range using Java, and I've come across this Stack Overflow question with quite a few upvotes. And so I understand the question at the top, so I'm not going to read too much into it. And I'm just going to find the most popular answer, or what looks like it for now. Let's see if this works. So you've got min plus math random times max minus min plus 1. All right, so let's copy that and paste this into the first one. Now let's replace min with a value. So I expect the min to be 0, nil goals. You can't have -1 goals. And the max I'm going to say is 5. Okay, and I'm going to repeat myself a bit here by copying and pasting the same logic into all of the goals away and goals home. So let's recompile this. Successful compilation. And let's play. Barcelona 10, Real Madrid 5. Oh dear. Barcelona 1, Real Madrid 1. Extra time. Barcelona 7, Real Madrid 5. So what we can see, just by adding this dynamic math.random in, which provides us a value between 0 and 1, I believe, and then timesing it by the maximum minus the min plus 1, we're able to generate this this random value. And because we've got these zeros, we can actually simplify it further. Because we know anything minus 0 will be the same. Here we go. We can take away these extra brackets as well. Okay, so there we have it. So this is how we can generate a random result. We recompile it just to check that we haven't broken any syntax rules and run it a few times more. Fantastic. Now we've got football that could almost be real. Finally, we have the ternary operator, which is the last point we're going to be covering in this lecture. So we go back to edX, and we've got this nice little tool in 1.4 in the first video here, where we can try it out for ourselves. So we've got this statement. N is less than 0, question mark, x equals minus n, colon, x equals n, semicolon. And what this means is that if this value evaluates to true or false, it'll do something after this question mark. If it's true, x will equal this. If it's false, x will equal n. So at the moment, n is less than 1. N is less than 1. X becomes 0. As n is less than 0, x now becomes minus n. Minus 1 is 1. Great. So let's try something that's not less than 0. 99. N is 99. X is 0. As n is greater than or equal to 0, 99 is now assigned to x. Great, so what's happening with this initial value of x? Well, actually this initial value of x isn't changing any of this calculation. X is just assigned in a value to start off with, but it's not actually part of this test. So the value of x will be replaced dependent upon whether n is greater than 0. Sorry, n is less than 0 or not. So we see here, n is 99, x is minus 5, but it doesn't matter because x is going to get replaced in the next line. So if you're interested in having a more one-on-one experience, you can join my section at mentiv.co. Read a bit more about me and get to learn, why I'm so keen to teach people about programming. feel free to reach out to me. I'm a very easygoing guy, so I'm looking forward to hearing from you, and hopefully we'll see you in section.